Okay, so hi everyone. So today in this video we are going to do this question from Leetcode that goes by the name non-negative integers without consecutive ones, and this will be our fourth video on this digit playlist. So before starting this video, if you are new to this channel, then please consider subscribing this channel because there is already a lot of amazing content related to competitive programming and DSA which can be helpful in your interviews or online assessment tests. So yes, if you're new to this channel, please consider subscribing it. And if you want to practice digit DP, then here I have created the dedicated playlist. So currently there are 3 videos and this is going to be the fourth video, and already apart from it a total of 9 videos is present related to the segment tree, and each one of these questions present here is very good for practice. Now let us get back to the problem statement. So the problem reads like this, that you'll be given a positive integer n and you have to return the number of integers in this range from 0 to n inclusive whose binary representations do not contain consecutive ones. So what does this mean? So you will be given an integer n, let's say n equal to 5, right? And what you will do is, starting from 0 and going till this n, that is 0 till 5, for each of those integers you will write their binary representation like this. So here as you can see that the representation from 0 to 5 is written, and the question has said that you have to return the count of those integers whose binary representation do not contain the consecutive ones. So if you look here, then the binary representation of 0 is just 0, in which no 1 is present. So it means that there is no consecutive ones present in this, right? So that's why it will contribute +1 to the answer. Similarly, the binary representation of 1 will just contain this one, that is a single one, that is no consecutive ones. So that's why this will also contribute +1 to the answer. The binary representation of 2 will be this, in which only one digit 1 is present. So that's why this will also contribute +1 to the answer. But this 3, the binary representation is like this, right? That is 2 1 is coming consecutively next to each other. That is, it is violating the problem requirement. So it means that this 3 will not contribute to our answer. And if you move forward, then this 4 and 5. So as you can see that for 4 only 1 is present. That is, it will contribute +1 to the answer. And for this 5, there are 2 1s present, but they are not consecutive. And since they are not consecutive, it means that they will again contribute +1 to the answer. So that's why out of this 0 1 2 3 4 5, every integer will contribute +1 to the answer except this 3. So that's why the output expected is 5, right? So I hope you have understood this problem requirement. The same thing will be done for these examples as well. So the constraint here, as you can see, is pretty high, that is going till 10 to the power 9, right? So this is the problem. So what approach we will apply here? So now first try to understand why this is a digit DP question. So as I have explained you in the previous videos as well, that for a digit DP problem there are 3 indicators. First you will be given a range. So since here you are given this range, that is from 0 to n, so this is the first indicator. Second indicator will be that the constraint will be unusually high. So here if you see, then the value of n can go up till 1e9, right? So this is the second indicator, and the third indicator is that in this range you have to just return the count ultimately for some specific integers only. That is, you have to reject some integers and accept some integers as an invalid answer and valid answer respectively. So that's why this is a digit DP problem. So if you are watching this video directly and you have not yet studied digit DP, then I will highly recommend you to watch this first 3 videos, then only come back to this video, because it will help you to build up the concepts related to digit DP and the states we use slowly. So that's why if you have not yet studied digit DP previously and you are watching this lecture directly and hoping to understand each and everything at once, so this is not going to happen. You first have to watch these 3 videos, or at least the first video, right? So once you do this, let us now try to understand the problem even in more depth in the blackboard. So let us go to the blackboard now. Okay, so since you know that in this question we are given a range something like 0 till n, right? And we know that from the previous video what we do in this first. So what we do is, instead of trying to calculate the actual answer for the given range, we do not calculate it directly for that range. Rather than we apply this prefix sum technique, that is, we first calculate it for the rightmost part. So since here the rightmost part in the range is n, so we calculate the value of function for that, and also we try to calculate the same thing for the leftmost part as well. So since the leftmost thing here is 0, that is from 0 to n, then 1 less than it, that is 0 minus 1, which is minus 1. So it means that for this part we now want to calculate the answer in this range, that is from 0 till minus 1. And we know that in this range, that is from 0, starting from 0 and going till minus 1, in this direction there is actually no integer. And since there is no integer, it means that there is no answer possible in this range, that is the answer will be just a 0. And since solve of n minus 0 is just this solve of n, so it means that our whole focus will be on this only, that is for the rightmost part calculation, and we are not at all worried about the leftmost part here. So once this thing is clear, let us move forward. So the thing is, what is actually different in this problem in relation to the previous problems? So in the first 3 videos, what we did is that we were simply converting the given n into a string and we were iterating on that string, because in those problems we did not have to do anything with the binary representation of the given n, right? But in this problem here, the binary representation is important. That is, if the value of this n is 5, then we know that the total number of integers will be like this, that is from 0 to 5, right? So instead of being worried about these integers, we are worried about their binary representation, that is if their binary representation contains consecutive ones or not, right? So that's why what we will do is, instead of converting the given n into a string, we will first try to write the binary representation of the given n. So since here n is equal to 5, so first we will try to write this 101 like this. And now we will apply the same technique that we used to do in the previous problems. That is, we will start iterating on this binary representation. First we will convert the given n into its binary representation, and that binary representation into a string, so that we can access the elements or the digits one by one. That is the bits one by one, starting from the left side and going till the right side, and then just applying the same technique that we did previously, right? So I would say this problem is not much of a difference. The only difference is that instead of operating directly on the given n, we are just doing it on its binary representation and nothing much, right? So since the value of n can go up till 10 to the power 9, so let's consider a value of n by ourselves. So let's say the value of n that I am considering here is something like, let's say 724, right? That is a 3-digit number, which obviously lies in the given constraint. So what I told you that since we do not have to do anything with this value of n, rather than we should be worried about its binary representation, right? So what is the binary representation of this n? So if I write here, so the binary representation of this 724 is something like this, right? So this is nothing but 724 only, so keep this in mind. So now since we know that this is nothing but the binary representation of 724, right? So our task is now to check for each and every integer present between 0 till this 724 whether their binary representation contains some consecutive ones or not. And also let me tell you one more thing. Since you know that 724 is actually an integer and its binary representation should contain a total of 32 bits, right? But here I only have drawn a total of 10 bits. And why I have done this? Because before this one, each and every bit present till the 31st bit, if we are considering that this is the 0th bit, this is the first bit, then after this one or before this one, each and every bit present in this range must have been 0, right? So if each and every bit must have been 0 in this range, and we know that since in this range there would not be any one digit, so it means that there won't be also any consecutive one digit, right? Let me tell you again. So we know that before this, each and every bit present would nothing but just be 0, right? So if each and every bit present in this range would be 0, it means that there won't be any bit which would consist of 1, that is a set bit. And if it is not 1, then it also means that in this range you will never get 2 consecutive ones, right? So that's why this part will never create a problem. Only this part can give you consecutive ones if there is one, otherwise not. So that's why instead of starting from the 31st bit and going till the last, we are starting on that bit in which we are encountering this one for the first time, right? So I hope you got this point. And so once this thing is clear, what will be our next task? So as you might have guessed, we will do the same thing that we did in previous problems. That is, since here a total of 10 blocks are present, So that's why I will consider 10 independent blocks here. So let me do that quickly for you. So these will be our 10 different blocks. So let me index them also. So this is the 0th index, first, second, and this will go till the 9th index, right? And we will start building this binary representation from the left side and going till the right side, that is from MSB all the way till LSB, right? So let's do this now. So let us now try to fill each one of these blocks one by one, starting from the left side and going all the way till the right side, right? So since for the first block here the actual value present in the string is 1, so that's why we have two choices here. Either we can fill it with 0 or we can fill it with 1, right? So suppose I decided to fill it with 0. So if I fill it with 0, then what will happen? So if I fill it with 0, then we know that whatever for the remaining blocks we will fill it with either with 0 or 1, then the entire binary representation will never be able to get greater than this and will always lie in the given range, and it will be a valid one, right? That is, if I choose 0 here, which is not the actual upper bound value present in the string, then the condition of tight for the remaining section will turn to be false. That is, the condition of tight will become equal to 0. But instead of this 0, if I select 1 like this, then it means that for the next block also I can only select it starting from 0 and going till whatever value is actually present on that index. So since here only 0 is present on the first index, so it means that if I select 1 here, then here for the first index I can go from 0 till 0 only, right? So let us now try to take one of these two possibilities and fill every block here. So let's say I decided to select 1 here. So if I select 1 here, then clearly for the next block I can only fill it starting from 0 and going till 0, that is just 0. So we must fill it with 0 only, and once we fill it with 0, then again we will move to the next block here, and we now again have to decide what digits we can fill it with. So since for the second index here the value written is 1, right? And since the condition of tight is true for this as of now, why? Because whatever digits has been filled till now, it is actually matching in the given string. So that's why for this block also the condition is tight. So since for the second index it is 1, so it means that we can fill it starting from 0 and going till 1. So suppose I decided to fill it with 0. So if I fill it with 0, which is actually not the upper bound value present in this string, then it means that for the remaining section now, the condition of tight will be false. That is, for each one of the block we can fill it either with 0 or 1 as we want. It will never get cross this limit, right? So suppose I decided to fill it with 1 now, and after filling it we will move to this next index, and again since the condition of tight is already broken, so it means that I again fill it, so it means that I can again fill it with 0 or 1. So suppose I again decided to fill it with, and if this is the case, then what will happen? It will see that current digit that I have selected is actually matching to the previous digit. So we'll keep a record of the previous digit always. So if at any time the current selected digit becomes equal to the previous digit, it means that is the current digit selected is 1 and the previous digit was also 1, then it means that we have got two consecutive ones. And since in the question it was written that whenever two consecutive ones will be present in the binary representation, then it will never contribute +1 to our answer. So it will not contribute +1 to our answer. So that's why moving forward and filling each one of the remaining blocks is not feasible anymore, because no matter what you will fill here, for the complete block you have got at least two consecutive ones already. So the formed representation will never contribute to our answer. So that's why moving forward is not feasible, and we will just stop at this point. Right, so I hope you got this important point. It was very important to understand this thing here. But suppose instead of this one I selected, say if I select 0 here, then what will happen? So nothing will happen, right? Everything will be alright because no consecutive ones is present as of, and again I can move forward. So if I divide the representation into two cases here, then it will be something like this, that for this range the value of tight initially was true, right? Because when we selected 0 here, then the condition of tight was true previously and we selected the upper bound. So that's why for this state also, that is for this index also, the condition of t was 1 only. That is, we could have selected it from 0 till this 1, and since we selected 0, that's why for the remaining section the condition of type will be false. So that's why for this section the type was turned false, right? And the same thing can be done for the whole blocks. So let's say now we moved from this 4th block to the 5th block, and the condition of type is already false. So what we can do is we can either select it with 0 or 1. So let's say we select it with 0, then again in the next block we select it with 1, then with 0, then 1, then again 0, and ultimately we will reach this 10th index, which is the size of the given string. So once this size will become to the 10th index, then we will conclude that our binary representation is successfully formed. And if it has formed successfully, that is the value of idx equal to 10 has become equal to the size of the string, it means that the given blocks has been filled in such a way that we will never chose any two digits such that both of them were 1 continuously. If we had any situation like that, then we would have just stopped at that point, right? We would have just stopped at that point and will not continue ahead. But since we have reached the destination, that is the end, so it means that we never got this situation in creating this particular representation. That's why this will contribute +1 to our answer. So if I had to write the states here that will be present, so the first state will be nothing but the idx state. As usual, you must be knowing this because every time that it is getting increased by 1. The second state will be our type, and our third state will be nothing but this previous value. So we will have a record of the previous digit every time if it was 1 or not. So if it was 1 and the current digit is also 1, it means that we should stop here. We will not continue ahead, right? So these two will be Boolean type and this will be integer type. So this is the whole logic for this problem. We don't have to do anything else further, I guess. And since we have already eliminated the leading zeros present initially in the string, and why I have told you that, so since we have already eliminated that, so that's why leading zeros will never create a problem in this problem anymore. So that's why we are not considering that 4th state of leading zero here. So once this is clear, I think it should be very good for us if we actually move to the coding part and code this up. So let us go to the coding part now. So what I told you that first we will convert the given n into its binary representation, and that binary representation into a string, right? So I will form a string s, and I hope you know how to convert the given n into a binary representation, right? That is, we will use this bitset function. So if you do like this, then what it will do is it will convert the given value of n into its binary representation, and that too into a string, right? So something like this. And once this is done, we know what we used to do. So we eliminate the leading zeros because we know that the leading zeros will not play a crucial role in this problem because it do not contain any consecutive ones, right? That is, we will try to start from the first set bit starting from the left side in this string. That is, I will check the index of 1, that is the first one present here. So how we will check this? I will just say s.find this one. So it will give me the index of the first, and starting from that and going till the last will be our actual string. So that's why I will say s is equal to s.substring starting from this index actual. And once this is done, that is our required string is formed, I will call the function, and whatever it will return, I will simply return that answer. So let me pass this string here like this. So let us start writing the function now, right? So the name of the function is f, and the first argument is this string s, right? So we know that the second argument here will be nothing but the starting index, which is 0, right? So this will be idx, and the third argument here will be the value of type variable, which is initially typed, that is true. So bool of type, right? And also, since we want to know the status of the previous variable every time, so we can say that initially it is false, that is consecutive ones is not detected yet, right? So bool of previous. So once I have written the 3 states here, let us start writing the base case now. So it would be very simple. If the value of this index will be equal to s.size, so if this is true, that is the index value is becoming equal to the string size, then it means that the binary representation is formed successfully. So we will return a true directly here. But if this is not the case, then we know that our lower bound value is equal to 0 and our upper bound value will be nothing but decided by the value of tide. So if the value of tide is true, then we know that this can go up till s of idx minus 0, otherwise till the maximum possible value, that is 1. And now we had the liberty to select digits starting from this lower bound and going till this upper bound and increasing 1 by every time. So as I told you that if the current digit that we are selecting is equal to 1 and the previous digit is also 1, that is the boolean value true, then it means that it represents two consecutive ones and it will not be a part of our answer, right? So we do not have to include it. So that's why we will just continue from here. But if it is not the case, then it means that the answer that will be formed is valid as of now, right? So it might contribute to our answer. So that's why we will move forward with this and we will again call the same function and the string will remain s, the index value will get increased by 1 and the tide value will depend like this, that is initially, that is if the condition is tide till now and the digit that we have selected is equal to the upper bound, then this. And also the previous value will be like if the current digit we have selected is equal to 1. So if the digit that we have selected here is 1, then it means that the boolean value for the next iteration, that is this previous value, will be equal to true, that is the previous value was 1 indeed. And at last we will just return our result like this. And sorry, this will be double and not or, right? So this will be and, that is if the current digit we have selected is 1 and the previous digit was also true, that is 1, then it means that this is two consecutive ones and it will not be a part of our answer. So that's why we will continue from this. And now if we run it, then let's see if we are correct or not. So as you can see that the test cases are getting passed here, but obviously this will give a time limit exceeded because the value of n can go up till 10 to the power 9, right? So let's define the dp table here. So since we are given with 3 states here, so that's why it will be something like this. So let's write it here. So if the dp of this is not equal to minus 1, then we will return the existing value, right? That is this, and also store it here. So let's name it now. So this will be idx, this will be tide, and this will be previous, right? Similarly, this will be idx, this will be tide, and this will be previous, and same for this. And let us now try to understand what will be the sizes for each one of the state. So since the second and the third state are both boolean values, so that's why it will be 2 for them. And let us now try to think what will be the value of index. So since here the value of n can go up till 10 to the power 9, so if you try to write the binary representation of this 10 to the power 9, then the binary representation of 10 to the power 9 will be something like this, right? And we know if this is the case, then what we'll be doing is we'll be start iterating from the 0th index here, right? And we'll go all the way till the last index. So this will be our 0th index, first, second, and so on. So this will correspond to what index or what number? So this will be nothing but our 29th index, right? So this will be our 0th index and this will be our 29th index, and this will be the maximum case, right? So in order to access this 29th index, you must declare a size of 30 at least for the index state. This will be nothing but 30, right? And let us also do a memset here. So memset dp minus 1 size of dp. So let us now try to run and see if we are correct or not. So as you can see, the test cases are getting passed. So let us now try to submit the same code and see if we are completely correct or not. So as you can see that our solution is accepted now, right? And this is the code that we just wrote, and I have explained you each and everything in very detail. So yeah, thank you so much for watching this video till this point. If you think you understood something new or found it valuable, then please consider liking the video and subscribing this channel, because I'll be uploading more and more videos like this in the upcoming days, right? So only if you support me, then I will be able to make these videos regularly. So yeah, thank you so much for watching this video. Thank you.